today it will be more about the real-life Docker things. It will be about the development with Docker on localhost. So, but first, we have some technical debt from the last session. If you remember the Docker file I was coding, it looked something like this. And there was one problem with, I should make it larger. Command class. Yeah. Is it better or larger?
You see?
This is better. Now it's hard for me to manage it. Okay, but there was one problem. It was, I believe, yeah, it was here on this line. I was assuming that this copy command assumes the Docker ignore file and that it ignores all the things included in Docker ignore file. But if you are copying from one stage to another, it actually doesn't. So we did some adjustment in the Docker file, and now it looks like this. The left one. By the way, thanks to Jirka, who noticed that. And so right now, what we basically did is that we switched the stages. So the first stage, the base stage, basically creates a production configuration. So it sets up a user with constraint permissions. It copies the package and package log JSON, and it installs production-only dependencies. And after this stage comes the stage called source, and it just copies the source code. And if you target the production, basically nothing changed, just the command is added. And if you target the development, only development packages or development dependencies are installed. I intentionally omitted the tests and linter because we have some different intentions with these we will see later today. So this is like a quick depth from the previous session, and yeah, so this is what I basically did. And today's session, what's gonna be about? We will talk a little about Docker networking, about how to manage data also outside the containers, and about Docker Compose. So at first, Docker networking. There are basically 4 network types which can be attached to the containers. The default one is called bridge, and it basically allows you or guarantees you that the Docker containers, those are in that specific network, can see or address each other, and containers, those are not in that network, they are not addressable among each other. So it's the default one. So if you don't specify anything around networks, your container will be created in the bridge network, and if you don't specify anything, as I said, it will be created in the default bridge network, which is one created in Docker by default. But you can also create your custom bridge networks. You can obviously have multiple networks in your Docker environment to just have your containers separated. Then the other network type is called none, and it basically just isolates your container from all networking. The other one is called host. This is really interesting one. It basically manages that your Docker host shares the networking with the host, with the computer where the Docker is installed. So, but this works only on Linux. It's not possible to do this on Mac or on Windows because, as we said last time, the Docker on Windows and on Mac is running like virtually. And the last one, it's called overlay network, and it's useful when you have a multi-host environment. So when you have some cluster of virtual machines, and it allows you to connect multiple Docker daemons, and it allows you to create like one network like all over the host, so it can or everything can communicate together, even if the hosts are like physically separated. Do you want to ask about anything related to networks? It was just theoretical. If you haven't ever met networks, you are using the bridge one. But it's good to know something about it. Now, how the containers can be linked? Basically, the linking containers, it basically consists just on giving containers a unique name in a DNS scope. There is like one legacy way how the linking containers was achieved, and there is a flag link, so you can like link the containers manually to say that one should like see or be able to address each other. But it's a legacy way from previous versions of Docker. Right now there is a recommended way, and it's about to create a bridge, custom bridge network, and put the containers into that. And this, by default, will manage this container linking, and it will does also more for you. By default, each of the container which is running has the IP address assigned, for example, like this. And you usually give the containers. So if a container has some name, they always have to have names. And for example, if the name of the container is container1, this kind of inbuilt service discovery feature allows you to address the containers not by IP address, but also by the name of the container or of the service. So it's very useful because when you start a container like again and then you stop it and delete it and start it again, the IP address can change. So this service discovery is very useful when you want to address different container in the same bridge network. And now something about data management. Oh, there is a picture. Basically, Docker containers or their storage is by default ephemeral. So it means when you destroy the container, all the data that it created inside, they got lost as well. So, but sometimes you need to persist the data somewhere. There are some ways how to store data on the host machine. Two of them are like persistent, and one of them is not. The first way is to using bind mount. It provides you a binding to the host file system, but to the exact part of the host file system. So it has some, let's say, disadvantages. For example, imagine when you want to port your Docker container to some other host, then there can be some discrepancies in the file system, and so it can create issues. But this is usually used when you want to mount some specific file, for example, some system configuration or sometimes some credentials. It's not a good practice, but it was also used to this. To basically target like anything specific from the file system. But if you want just to store the container data somewhere to be persisted. It's better to use volumes because they are like stored to Docker managed area, which is not like dependent on the type of the file system or on the file structure that you have in your file system. And the third one is called TMPFS, and it basically mounts a part of the host memory, the RAM memory. So if you want to achieve some performance, it's good to use this one, but this one is also stateless. So it's for some, it's a temporary storage. It's really fast, but but you have no guarantee that it gets persisted because it's stored in the host RAM memory. That's probably all. And now something about Docker Compose quickly. What the Docker Compose is, it's a tool for defining and running and managing multiple containers. Docker Compose, there are, let's say, 2 supported versions of Docker Compose. There is version 2, which is like preferred to use on a single host, and then there is version 3, but we will talk about it later next session. That is for multi-host environments, but this is for version 2. For local development, you should use version 2 because you are developing on single host. Docker Compose uses a YAML file to configure every service, like a container. You can see it doesn't like abstraction upon the containers because it adds stuff like container replication, for example, if you want multiple instances of the of the containers. So it calls it service, and you are like abstracting upon the group of containers of the same type, and you call it service, and you can do like whatever management with that. So you can, for example, start all the containers defined in the compose with a single command. You can stop them, destroy them. You can just run part of them. You can build them. You can whatever. It's just a tool for management of multiple containers in an easy way. It's also sometimes called the simplest orchestrator. Docker Compose is called like that sometimes. It's a joke, but but it has some common attributes. So some features of the Docker Compose. You can achieve with Docker Compose. You can achieve to creating like multiple isolated environments on single host. It can manage volume data. Those are containers like create or use. And another feature is that when you run Docker Compose, it only recreates the containers that have changed, which means that if you don't change like any of the images or containers and you run Docker Compose again and again, it won't like build them again and again, and it will just use the running instance that are only stopped. So it gets some performance optimizations or time consumption optimizations for you. Common use cases of Docker Compose, obviously, when you are developing some applications and you want to run and test multiple containerized applications together. In automated testing environments, you can basically test like containers against each other. And, you can like spawn like the container infrastructure, and you can test everything together. So you basically achieve the production experience. And the Docker Compose, this is for version 2. You can use it for single host deployments very easily. And this is a sample how version 3 Docker Compose could look like, but I believe in this sample it's the same as it would be version 2. So the core part of the Docker Compose is the version section and the services section. I believe those are the only required. And in the services, there are defined all the services that are like managed with the Docker Compose. And so there are some additional properties or configurations related to these services and how they can be built and what should they expose, what port, and which are tied together, which not, and what image they use, and so on and so on. You will see in a moment in practical example. Okay, so now I would give a word to Juan, who is better coder than me,
Okay.
to show you some practical experience from development with Docker.
Yes. So I think first I want to take the previous image again to go through every part and explain what's going on here comparing of the previous session. So as you can see, we have the version that's necessary. It could be either 2 or 3. And then we have the important part, which is the services. Why Docker Compose puts services instead of containers is because the version 3, what we are going to see in the next week, is used for orchestration with Docker Swarm. So when you're orchestrating, you probably want to replicate some containers. So that's why it puts this abstraction word, which is services, because one service could contain the same container but replicated many times. So that's why the name changes there. And in this example, we have two different containers, very different, because as you can see, the last one, which is Redis, it only contains image and the name Redis. And it means that the image will be pulled from the Docker Hub. It's not built in the host that is executing this file, but pulled from Docker Hub and executed afterwards. And the web is different. It starts with build and a dot, and that basically points the context where the Docker file is. Then we have ports, which basically will expose the 5,000 port to the host. And then we have the volume section, which contains two different ways to manage the data that Martin just mentioned. The first one is the bind mount. You can see that we have dot, colon, and then slash code. That basically the left part is the host part, is the host like a file system, and then next to the right to the column we have the container file system. So basically we're mounting everything in the current directory to the slash code directory inside the container. And the next one is a name volume, because as you can see at the very bottom of the file you find volumes, and then you have log volume 001. So basically this is like giving an alias to this volume that is going to be stored on the reserve area on the host. So here we have, even that is named volumes, we have different type of managing data. The first one is bind mounts, and the second one is real volume. And then we have links, Redis. This is kind of like to tell it's kind of like a documentation, because right now links is kind of deprecated by default. Everything is linked, but it's like telling like, okay, this web service is depending on the Redis one. So that's basically it. So yeah, let's start with the demo. First, I need.
Oh, I will help you.
Thank you.
I don't know the password.
Yeah,
Do you have some?
Yeah, no, my finger is okay. Okay, yeah, this is okay. So we go to the previous example. So we are going to forget about this old file, which is broken. We keep this one. So we have this container, which is basically ready to, let's say, run to production. But we want to, since this session is for the Docker for development, we want to achieve or prepare this stage over here, which does nothing so far. I mean, if I build this image and target depth, it will not do anything. As you can see, the command is not specified here. So this basically, this image will be like, it will execute and then turn off, because remember that the process needs to be bind to the container. So if there's no like a demonized process, the container will shut down basically. So okay, let's fix that. So well, first we need to show that the app changed a little bit. We still have our app, yes. And our greetings, which basically prints Hola Mundo and the environment. That's great. But the app changed a little bit. As you can see now, we're using some database, which basically is behind the scenes is using nets. And as you can see on the listening part, on the callback, we are basically checking if the connection is available or not. And if it's not, we shut down the container. And the shutdown basically will destroy everything. Okay, and another thing that's changed is that now we're handling signals. And this is very, very important, not only for Docker, but for every Node application. By default, Node listens to signals, but if you don't specify what other action that needs to be done after that, they basically do nothing. So there's one important thing, like for example, sigin is basically like replicating a control C if you're running Docker. And sigterm is basically what Docker sends to the container when you're doing Docker container stuff. So this is very important because otherwise, Docker eventually will shut down the container, I think after 10 seconds, but it's better to have it handled because you probably want to close your connection, you want to send some theme packages. I don't know, you want to close like in the good way. And, and also, there's one important thing in the Docker file, a recommendation. Never run your application with npm. This is bad. This is evil. This is because npm, even that your app, imagine that you have something like this. Even that I have this over here, npm is the process that I'm forking. Is the process that the container is like initiating. So it doesn't listen to the signal. So this is very important. Okay, always run node directly. So let's get started, I guess. So the first thing is like on the database, on the index, we have something. I mean, like we're trying to connect to some Postgres database, right, on localhost. That's great. And we created this directory which contains some like initialization for the database, which basically create a database, create a table full on it, and insert one column, one value. Sorry, and so that's pretty basic. So the first thing we're going to do is to like run this database and try to connect to the using like the linking that the Docker provides. So the first thing that we need to remember is that by default, if we click on this Docker network ls, we can see all of our networks. So okay, right now we have like many.
Those are mine.
Yeah, let's clean this up because. Oops, it didn't work. Okay, if we do again, oh no. If we do network ls, we're going to have three different. Ignore this one. I don't know what it is. But the thing is, like the default one is called bridge, and the driver is bridge. So it means like it's the normal bridge driver. We have the host. Even though we're in Mac, it doesn't work. So forget about this one. And the none is basically using no driver. It's a closed container, right? But the thing is, like we need to, in order to like communicate to containers by default, we need to create a customized bridge network. And this basically, let's do Docker network create. Let's call it Hola Mundo. And if we do again ls, you can see that it's here, and by default it's bridge, right? That's good. So the first thing we need to do is get our database, right? So let's put Docker run, detach mode. Let's name it Hola Mundo DB, I guess, yeah. What else? As you remember, we have this script over here. So we want to pass this script to the Postgres container. So the way to do this is with byte mounts, because we want to like kind of replicate this directory to the directory inside the container. So for this specific container, I will go. Oops. I will go to, do you have Chrome? Oh, yes.
Shall we look in? Okay.
Yeah, if we go to the Postgres Docker image, which is the one we're going to use, the official one, they have a script, sorry, a location where you can put these scripts. This change on every like different container, but this is this is specific to this one. And for the Postgres container, you need to put whatever you want to initialize on this directory inside the container. So we know that there is a / docker entry point / initdb.d. So that's great. So we copy this. So the way to bind a volume is first put -b, which is the volume, and then we want to mount our current directory /.db, which is this one, and then /initdb.d, and then colon, and we copy the directory inside the container. So that's how we bind mount the one directory into the container. So that's great. We have docker run, detach mode, name holamundodb, the bind mount.
Image name.
Yeah, before putting the image name, we need to specify the network that we just created, because otherwise it will put on the default bridge network, right? So it was named Holamundo, right? And then we need something else. No, I think that's pretty much it. Oh no, yeah, we need the port, right? By default, Postgres listens to this one, and also from the container. So we're going to post this container, put this port in the host machine. And then after that, we can just post the image name, Postgres, the version 10, Alpine, because it's the lightweight version. And I think this will work. Oh, no. Oh, there's something. Let me check something. Yeah. I will do something quickly. Oh, no.
Docker system.
Yeah. Yeah, we have some containers already running.
Just rename it.
Yeah, I will, yeah, to put it quickly, I will just
rename it.
Yeah, the thing is like it's running on the same port probably.
Oh.
Yeah, we need to kill it. Or not. Okay, something.
It's a graceful shutdown.
Yeah. Okay, now we're going to delete it. Okay, so now I'm going to create the container again. We should create it, and we'll just assume that this happened. It happened. Trust me, because let's check the logs. Hola mundo. This is an interesting command. Docker logs. You can basically put the name and you can see the logs. So you can see that it took the init thing, create a database, you're connected now, inserted the thing. So that's great. So everything, oops. Yeah. So that's great. Okay. So now, I think if we run this, source up, yeah, you can see that it works. This is locally, this is not in Docker. I mean, what we have Dockerized is only the database, but we're running in Node inside in the host machine normally. And it works because if we go to index, by default, if I don't specify this environment, it will go to localhost and the port. So it works. That's nice. But we want to like Dockerize everything, right? So the first thing we want to achieve is, instead of putting localhost, we want to put some kind of like a verbose name, not the IP address that Docker gives us. So since we named this is very important. It takes the name. Since we named this holamundodb, I will kill this holamundo API because that's one. Oh, okay. Sorry for that. Okay, so we only have one container, which is Hola Mundo DB. So that means this is, in this network, this is the DNS that resolved to this container, okay? So we're going to basically copy paste this here. H done, that's nice. And now we want to run this container, right? So first let's build it again, just in case. Hola Mundo API, and this will be like a production image, if that's okay. So it's going to build everything. So meanwhile, I will open a new terminal, I think. Yes. Meanwhile, we're going to write we're going to write the command to run the thing. So we're going to run in the foreground because we want to see what's happening in terms of detach mode. Detach mode is background, and when you put this -it is basically to activate an interactive shell inside the container. So we're going to run on foreground, then we're going to expose the port, which is 3000 for the API. Oops. We're going to, remove it once it's dead. We're going to name it Hola Mundo. You can see that to run a simple example, it takes a lot of flags. This gets fixed once we jump on the Docker Compose example. We'll see later. So don't get mad at me. So Hola Mundo API. What else we need? Yeah, I think pretty much it. I think Hola Mundo prod. Oh, we need something very important, which is the network. Otherwise, they will never reach each other. Network Hola Mundo. Oh no, it's not. That's not finished. Hola Mundo. It's called Hola Mundo API. Sorry. Hola Mundo API. As you can see, now this is running inside the container, and since it's in foreground, I'm attached to the shell, so everything is perfect. So if we go here, localhost 3000, Hola Mundo. So that's great. Okay. I'm kind of curious why they didn't send this one. That's kind of interesting. Yeah, there's something weird in this. Ay. Yeah, but something is weird because greetings is supposed to return an N, and I'm receiving only.
Some kind of.
Yeah, this is. Old. Yeah, this is kind of old. I will kill this. Oops. Terminal. What?
So, view.
View?
I don't know. I can do it in GUI.
Sorry?
I can do it in view.
Yeah.
For the what? Just after view.
Is
it called?
Yeah, here. Yeah, something happened here. That's kind of interesting. I will. Let's try to reboot it again, because this is where we're not getting the latest update, which is we should receive this JSON, not the old one. So that kind of. So Docker build tag Hola Mundo API prod, no catch. This flag is to avoid any catch, and then dot. What? So it's.
Oh, it didn't get the place.
Probably, you see. Yeah, let's see what happened here. So basically, well, as I mentioned, it takes a lot of commands and flags and stuff to prepare something like really works. So that's why Docker Compose it's here to save our life. I will show how we're going to create this. So, well, if this works. Yeah, everything seems to be okay. So, okay, now it's shut down correctly. Okay, so sorry. What the hell?
Still?
Yeah. Oh, yeah. I know why. Yeah, because node M is not defined, of course. That's why.
Oh yeah, it's not in the
Yeah,
file.
yeah. But that's kind of interesting. It's okay. We managed to have a memory leak on a very
I think
simple
we have
sample.
another.
Nice.
We have another technical debt until next session.
Yeah. Okay, this is interesting. Well, yeah, whatever. So the thing is like the thing is running, but of course the end is not defined so probably. But it's interesting. Anyway, so whatever. So we're going to start with the with the Docker Compose file, right? Because that's the interesting part. So first, let's kill this database because the Docker Compose is to define any kind of piece, any piece that it's needed to in order to app working. So if you need a Redis, you need a Postgres, you need whatever. So we need to stop everything that we have executed on the normal way, on the standalone way. So we're going to stop Olamundo DB. So it's that, and we need to kill it, like remove it from root. And let's check that Olamundo API is not there as well. Okay, so everything is okay. So let's create the Docker, the Docker Compose file. Oh, it's not here. It should be here. Yes. Okay. Yeah, it should be in the same like directory of the root of your project, basically. So the first thing we need to put is the version. As Martin mentioned, why we don't use the version 3? Because the version 3 is focused for orchestrated and production and
Multi-host.
multi-host deployments. And the version 2 still gets updated. So it's basically they're having these two branches, which one is for local and the other one is for real stuff, right? So we want local development environment, so we keep with the version 2. And also because the version 2, there are some like kind of interesting flags, or well, flags not, but features that are needed in order to achieve a great local development, which are deprecated, well, removed from the version 3, from version 3. So that's why we need to use version 2. And then we have, yeah, then we have the service, right? We basically have two services, right? The app itself and the database. So let's start with the database one. We call it DB. This is kind of an alias inside the Docker Compose file. So since this is an image which is remotely located, so we need to specify with the image field, which is basically the same as we put on the Docker run command. So 10.sits Alpine. So that's great. Then we could like use ports, but since we want to achieve like a complete Dockerized environment, we don't need to expose the port to the host. Everything will happen on this bridge network, right? So let's leave it like this. What else do we need? Oh, we need to bind this this script, right? So we put volumes, and it's the same. One cool thing is like, I don't know if you remember when doing Docker run on the database here. That's fine. Did. Ay.
Oh, yeah, too much.
Yeah? It's not here. Well, I don't know if you remember that when I was doing the bind mount on the console, that we needed to specify the both absolute paths. So that's why I used the pwd command. But here we can put how's the name? Relative path. Thank you. So we just put dot db initdb.d, and then colon docker entry point oops, initdb.d. Okay, that's enough, I think. And here's one thing. For example, since we're talking about database and Dockers by default are very ephemeral, so they will lose everything once you kill them. You can, like, well, this will be an ugly solution, but imagine that you want to save whatever happens on your database. So we could do something, another bind mount, which is .db, let's call data, and let's mount from the container whatever I write to this database. I don't want to lose the data, so I want to keep it on the host machine. So by default, I think Postgres writes into the /lib Postgres, I think, right? Didn't. It's not.
Data.
Yeah, I think.
Maybe it's /data.
Yeah, I think it's on the data. It should be like here.
r/lib/postgres/sql/data.
Okay, thank you so much. So what else do we need? I think so far we don't need anything. And now let's focus on the API service. Oh, well, let's do something because Docker Compose by default names the containers in an ugly way. I mean, it takes like the directory in, where you are located and it puts some numbers, and I prefer to always give it a specific name. So let's name it as the same way as we did previously. So it will be named HolaMundoDB. So that's great. That's just, this is just like, you know, to keep it like beautiful. So so here the API is not an image. It's something that we're going to build on the host machine. So it's we need to put build, and it gets context, which is dot in this one, and then we need to change the target. The target, of course, we want to, since this is like a local development environment, we need to target depth, which is exactly the same name as this. We're going to change this in a moment. So, okay, everything is okay. Image, if we put build and image, it basically is like which name I want to give to this container once it's built. So I want to be named HolaMundo API column depth with the tag depth, right? And then container name, blah, 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 and the API. Of course, here's we want to expose ports because we want to test our thing on locally. So 3000, 3000. What else? What else? I'm forgetting. There's one interesting feature on Docker Compose, which is called depends on, and it's basically to specify like a hierarchy of once you're building your whole compose file. So since this is the API that depends on the database, we need to specify that to the Docker Compose. So by default, if I do this, it will basically run the DB service first than the API. But there's one interesting situation here, is that it will run the container first, but it doesn't mean that the container is healthy or in this scenario that the database is ready to receive connection. And this sucks, and mostly because when we have something like this, let's say on a CI environment that we want to run our tests like very easily, it happens like probably the database will not be ready to receive connection. The API will start like, let's say, running npm test, and yeah, the database is not available and the test will fail. And there are ugly hacks like I don't know, sleep, and that sucks. And this is where the importance of having these two, the version 2 here, comes, because there's something that we can put here, which is called condition, in which condition this DB container should be. So there are two of them. The first one is service started, which is the default one, but we want the service to be healthy in order to start this start the API container. But the thing is, like, since we haven't put the healthy condition on the DB, we need to specify that like very specifically. So we need to put a health check here, and there are two things. The first one, interval, the seconds that the interval it takes to check if the service is healthy, and the test itself. So Postgres, this of course depends of any kind of like under service that you have under containers. We're talking about Postgres specifically. So for Postgres, this comes with a already built-in command, which is pg is ready, the user Postgres, and the host localhost. Why I'm putting localhost here? Because this command will run inside the container where the DB is, so it's localhost relative to the container. So with this, we achieve the API will get started once the Postgres is ready, basically. And this condition, if you go to the documentation of Docker Compose and the version 3, you will see that it's not existent. So this is very useful for local development. Of course, when real scenarios with orchestration and stuff, you should have like a very a best way to have these conditions and a customized way. But for local development, it's not that worthy to spend time of that. So I think that's pretty much it for the Docker Compose. The Docker file in the dev stage is doing nothing right now. We need to fix that, right? So let's first install, since we want to add a local development environment, we want to get the updates once we change something in the file. Let's go to the default way, which is no daemon, I think. npm install save dev no daemon. Yeah. So we're going to install no daemon. It will get installed here. So that's amazing. So first let's put m. I think this is very important when it's running environment and development mode. You need to set this flag, otherwise.
Assign.
Sorry?
Assign.
Okay. Yeah. Okay. Thanks. And one thing also that we want to, this is like a way to avoid using npx or npm. You know npm is evil, don't use it. So let's do an ugly hack here. Well, not ugly really, but let's, we are in app modules. We are in app. Right. So let's mount the node modules to the path. Oops, needs to be .bin. Then okay. And the last thing is basically run no daemon. So first no daemon, source app.js, and if you want, of course, you can put something like inspect if you want that debugger. So let's inspect. The thing is, if we do this, as you can see, the inspector is running in every network interface and is listening to this port. That means that we need to put this port also here. Okay, if we want to use the debugger of the VS Code or whatever debugger you want to use. So this is important, right? Okay, so I think that's pretty much it. So here's where we stop using Docker standalone CLI. We only use Docker Compose. So Docker Compose is docker-compose. And yeah, we can, you can use PS. Very much you have the same commands that Docker contains. For example, if we want to see the command, the service is running on under Docker Compose, you can use Docker Compose PS. You can use Docker Compose down to kill everything that you have here. Oh, we have something there. I think that was previous. So there's an important thing. Remember that the containers by default gets linked once you have a customized bridge network, right? Here, I haven't specified a network in any place. That's because by default, Docker Compose creates a network with some random name, and you don't care about networking. You basically, whatever you put in the same Docker Compose file, it's meant to be connected. It's basically, it's obvious to be like that. So, so let's just do. Oh, there's one important thing. Or yes, it's very important because there's one problem with this image right now. Is the fact that we're not using bind mounts, and we want to bind mount everything that we have in our code in order to no daemon detect the change that I make in the host, and then it gets reflected on the container, and then go no daemon, oh, something changed, I restarted, whatever, So we need to do that. And for the most common cases, you basically mount everything. So I want to mount everything, and where's the
To app.
to app, and that's pretty much it. So this is very important. And the bind mounts has like different ways of bind mounting things on the container, and by default is like they try to keep the updates like in real time. Like if something changed here, something changed in the host, in complete real time, and that takes like like takes works to the CPU or whatever to keep the things like in that status. So there's a way when you put the container part, you can put colon and then the type of the bind mount, and there's one called delegated. Yeah.
I think it's called consistency levels.
Yeah, the consistency levels, exactly. So the delegated one is basically like taking prioritizing the container side than the host, and that makes sense because we don't want to get the host updated whatever happens to the container. We want the other way around. We want to go to the host and prioritize that the change gets updated on the container and no daemon restarts and blah blah blah. The rest of the story. So this is basically performance recommendations. So yeah, let's try this thing, which will fail. I will tell you why. So Docker compose up is basically reads the file and start every kind of the container. So, okay, there's something invalid. API volumes.
I think volumes. You are missing the dash.
Oh, yeah, it's dash. Sorry. Okay. Okay, it's starting the database, you can see, but it will not start the API until the database is ready. So we need to wait.
You are waiting for the health check because
we're waiting for the health check.
It runs every 5 seconds. What?
Ay.
Yeah, sorry.
Okay.
Health check didn't pass.
Why? Probably. Let me check something. Yeah, we still. Yeah, we have the old database running, I think. Yeah.
Yeah, it should be DB. You have the port blocked.
Or something went wrong here. No, you can see that something went wrong when creating the database, because you can see that now I have a data directory on the host, which is basically the Postgres information. So let me check something. Let's try again, but this is very weird. Yeah, something's happening with the database. Oh no, it's there. Yay.
Yeah, the old one blocked the port.
Yes, exactly. So everything is nice, I think. So we go here. Localhost, you can see development. Nice, everything works. So there's one important thing here. Since we are mounting everything to the container, we're even mounting node modules and everything that is, because the mount ignores the Docker ignore files. That's one important thing, okay? But that's okay because we want to mount like everything. That's pretty much okay. But the problem with node modules is not happening with this example because there's nothing compiled. But once it's something compiled, remember that Docker, or for example, this the node base image, which is node 12-slim, runs on Debian, if I'm not mistaken. And that's Linux. We're running different architectures, or operating system architectures. So that means if there's something compiled, I don't know, bytecrypt or whatever, this won't work. I mean, like your dev environment will be dead. So one way to fix this is to, let's first kill everything. Docker compose down, stop any container, remove, you can see it, remove all the networks, and it kills everything, gets you like a clean state. So to fix that, we need first delete our local local node modules, because we want to achieve like a complete development life cycle inside the container. We don't want to do, that's the thing, if you want to go this direction, you cannot like run npm install on the host machine, or at least once you do it, you need to install the node modules inside the containers again. So the thing is, like, to fix this is basically docker compose run. Now it's not up, run. Run is basically to a single service inside the Docker Compose, which is API, and then the command that we want to execute. And we want to install, the things, like everything on the Linux environment. We want to, like, if we have something compiled, it's not this is scenario, but it most likely happening on normal projects. So that's in that way we achieve like a complete, like a no harmful way to run the thing locally with Docker. But that's the thing, we need to have this like a middle step, otherwise it won't work. There's another hack, but that's ugly as fuck, I would say, which is installing the modules during build time in the Docker file, then moving these node modules and folder behind, like let's say on your home node app, then you move the node modules to home, I don't know. And because by default node works like when you're requiring a module, it will not locally, it will go backwards until it gets to root. That's how node works. So in this way, you can achieve like having both local, like a host node modules with Mac binaries, and inside your container Linux binaries. But that's confused as fuck, and it works, but yeah.
Rather use this.
Yeah, it's better to use this like a middle step. So now, if we go now Docker Compose up, it will just work. So you can see it's no daemon. So if we go to, I don't know, greetings, whatever, lol, yeah. So everything started, hola lol. So yeah, you have like a complete function local development with Docker. So yeah, I think that's pretty much the sample. I think I didn't miss anything. Let's kill this. Let's clean everything, and yeah, I think. Any question?
Are you sleepy?
Yeah, it's very hot. So yeah, in the next week we're going to show like the deployment way, the deployed ways. It's broken. I don't know what. Sorry.
Deployment pipeline with
Yeah,
Docker.
exactly. With Docker, exactly. Show
to
different,
anywhere. What is supporting Docker?
Exactly. Basically, show different orchestrators, and we're going to probably show a little sample with Docker Swarm. Why Docker Swarm? Because since we can reuse the Docker Compose file easily and just put in the version 3, and then we have different like fields, like replicas, whatever. We're going to see the next week, but at the end we can use whatever we want: Kubernetes, ECS,
Heroku.
Heroku supports containers, and it works pretty well, I think. Until it doesn't, but yeah. Yeah, I remember Kaya had running something. Yeah, I think that's it. Thank you. Careful with the recording.
With the recording.
The click here.